Hello everyone, welcome to Code Crafters Lab. So today we are going to see the basic maths problem, that is check if the number is Armstrong or not. So here we are given with integer n and we need to check whether it is an Armstrong number or not. And what we want to do, return true if it is an Armstrong number, otherwise we have to return false. So what is a Armstrong number? It is a number which is equal to the sum of the digits of the number raised to the power of the number of digits. Okay, so what is it? Let's say we are given with n equal to 153, right? And it is a Armstrong number. Why it is Armstrong number? So there are how many digits in 153? 1, 5 and 3, which is 3. So what we are doing, 1 to the power of 3 plus 5 to the power of 3, then plus 3 to the power of 3, and we are having the sum basically, which is equal to 153, and it is equal to the original number 153. So that is why it's a Armstrong number. Then example 2, n equal to 12. So there are two digits, so we are doing 1 to the power of 2, then plus 2 to the power of 2, which is 1 plus 4, 5. It is not equal to 12, right? So that's why it's not a Armstrong number. In this case, n equal to 370. So 3's power 27, then 7's power 3, 343 plus 3 or 3, and 0 is anyway 0, so it is equal to 370. So we can return here true. So right, so let's try to understand this in depth. So let's say we are given the number as n equal to 370, right? So we know, right, what we want to do. We want to find the 3's cube plus 7 cube plus 0's cube, right, which is equal to 370, and then find out whether it is equal to n or not. So that we understood. So here, breaking this down, we need to find the each digit and then add the number of count to the power, right? So we know how to find each digit, extract single digit from the number. Yes, we have seen that in our previous examples, right? So what we used to do, we used to divide that number by 10. 370 divided by 10 basically, then 37 divided by 10, then again 10, 3, 0, right? So that is how we were eliminating the last digit, and we were getting the count as well as we were getting the last digit also using remainder, right? So let's try to write that. So we'll take the first number in sum, where we will store this sum, right? At each step we'll take it as 0. Then we'll do one int copy of our original number n, right? Why we are storing it? Because while traversing this loop, while n is greater than 0, right, till 0 we are dividing n by 10, n equal to n by 10, right? So that's why we are storing our original number, so that we will not lose it. After this, what we will do, int last digit. How we get last digit? By using the remainder n modulo 10, right? So what we want to do here, so sum equal to sum plus what we want to do, we have to take the last digit and its power. What is the power? Power is nothing but the count of digits. So we'll take one more variable here, int count. And how to find the count? We can find the count using log base 10 of n plus 1. So this is the formula to find the number of count. So in this case it will return 3. And what we'll do here, we'll use power function on last digit. What is the power we have to apply? Is a count, right? So that is how we can solve this particular problem. So let's try to code this. So what we'll do, int sum equal to 0, then we'll do int copy equal to n, then we'll do int count, right? Count equal to, we have to convert it into int, then mat dot log 10 of n plus 1. So this is how you can write it in Java. Then we'll do while n is greater than 0, what we'll do n equal to n by 10, right? And at the top we'll extract the last digit. In last digit, we have seen this in detail in our previous videos, right? Last digit equal to n modulo 10. This is the remainder. Then what we'll do sum equal to sum plus mat dot power. So there are different power functions in every language, so we are using it in the Java, so that's why we are writing in this way. So last digit comma count. So count we are getting here, so we have to add it to the sum, and at the end what we'll do if my copy equal to sum. If it is, then we'll return true, otherwise we'll return false, else return false in this case. Try to run this. Sum equal to sum plus mat dot power last digit comma count. Loosey conversion from double to int. Sum is int and mat dot power, is it doubled? Is it so? Let's see. Yes, it's accepted. So yeah, let's try to submit this. Yes, it's passing all the cases. So talking about the time complexity here, so time complexity, we know for this particular while loop, time complexity is nothing but O of digits. So how many digits we are running into? We are using power function right here. So power functions internal time complexity is log base 2 to the digits. So this is how our time complexity will be. And talking about space complexity, it is O of 1 because we are not using any extra space here, right? So yeah, that's it for now. Please like and subscribe to our channel, and please share this video within your circle so that your friends will also get the benefits. Thank you for watching.